Hello, James Flaten here with the Minnesota Space Grant. I'd like to talk to you a little bit about making graphs from data that was collected using a PICOLO flight computer, in particular, a PICOLO flight computer that flew on a stratospheric balloon flight. Before I look at some PICOLO data, though, let me just take a look at a graph that I consider fairly well made. Here we go. So notice in this particular graph, I have time on the horizontal axis, and it's labeled time in minutes. That could have perhaps said time since boot up. And the reason is I noticed that something which is labeled launch is not at the 0 time mark. Here's altitude in feet above sea level. Here's a title, altitude versus time. Notice that I put my initials here as evidence that I was the one who drew the graph. I have grid lines, both horizontal and vertical grid lines that go along with the numbers on the axes. And then I have labels. So this says burst or cut with an arrow pointing to this point, landing with an arrow pointing to this point, launch with an arrow pointing to this point. I drew this graph with Excel or perhaps Google Sheets. I have another video just like this one about Google Sheets. This video is going to be about how to do analysis with Excel. But those words burst or cut and launch and landing and those arrows, those were not drawn using Google Sheets or using Excel. What I did is I took a screenshot of a graph that I had drawn. I put it into PowerPoint perhaps or Google Slides, and I added the labels there. But anyway, I would consider a good graph to be one that has all of these features as well as quite possibly some labels to explain what certain features are. Okay, on to some data analysis. Here's where I have posted some data from PICOLO. This happens to be from Gopher launch flight number 231A. And here is the original data in CSV format. And what I don't want to do is I don't want to double click on it. And the reason is if I double click on it, it's posted in Google and Google will try to open it with Google Sheets. I don't want to do that. I want to open it with Excel. So I'm going to download it. So I'm going to right click and say download. I don't want to double click. I want to download it. So here's the data. And now if I double click on it, it will open it up using Excel on my computer. And the first thing I'm going to do is I'm going to save it in Excel format. So it's not CSV anymore. Now it's Excel. Let's look around. First of all, I notice this column here isn't wide enough to show me the numbers in the column. So if I double click here, it will at least widen it up. That's good. I notice there's a lot of data. In fact, wow, there's a lot of data. 11,119 lines. Well, the first line is a header line, but the rest of it is all data. And then many, many, many columns of data here. In fact, I can't even tell what the columns of data mean unless I go to the top and I can see the headers. The headers here explain what's in each column, so be very careful that your header is well lined up with the data below it. One comment is Excel is actually pretty good at handling this much data. Google Sheets, not so much. So right now I'm able to scroll up and down easily in Excel. In Google Sheets, things get pretty sluggish. For the most part, these are standard data columns from a PICOLO flight computer using its standard set of sensors. The exception is way off here on the right-hand side. I see two columns. This says hits and this says cumulative hits. Those are both related to a Geiger counter. That might be specific to the experiment that was done. I'm not going to try to analyze that data. I'm going to look only at some pressure data and perhaps some pressure data mostly, and for the purposes of this particular demonstration. Over here, I notice hours, minutes, seconds separated by colons. Oh, what a miserable way to write down the number. This is much more useful. Here are actual elapsed seconds and milliseconds. And so when I do graphing, I'm definitely going to graph against a time column, not an hours, minutes, seconds column. On the other hand, here's something I noticed that is missing, bothers me, and that is there's no time in minutes. I would much prefer to graph against the time in minutes column because 11,000 seconds, I don't even know what that means. 60 minutes or 90 minutes, I have a sense for what that means. So let me just add that column first. I'm going to click to the right of the time in milliseconds column. I'm going to right click and say insert. And so now it has opened up a blank column. I'm going to call this column time in minutes. So I put the units inside of braces, parentheses. In fact, I'm even going to kind of color this column just to keep in mind, to remember that this was a new column. This was not in the original data set. Now notice, if you are programming a Piccolo and you think you need a time in minutes column because you want it later, I would suggest just log a time in minutes column. And don't, then you could skip all of this, what I'm doing right now. Here we go. Time in minutes would just be equal to, I'm going to calculate it based on time in seconds. So take that number, I just clicked on B2, and then I divide by 60, and I hit return, and it gives me 0.40867 minutes. Probably more digits than I need. If I double click on this little corner here, it does the same calculation all the way down. And if I click on the top of the column and say format cells, number, here I can decide how many decimal places I want to keep. And the answer is I want to keep probably 2. Good. So the idea is here I see 30 seconds, 31 seconds, 32, 33, 34. This is logging about once a second. And it turns out that if I keep 2 digits, that's adequate for there to be a new number every time I have a new line. That's good. A few more things to notice here. One is that the latitude and longitude clearly start out incorrect because they say 999. There is no such thing as latitude 999. And then they say 0. And although that does exist, it's nowhere close to Minnesota, that's for sure. So frankly, the latitude and longitude are wrong. That just means the GPS hasn't locked yet. In fact, I can tell the GPS hasn't locked because it has 0 in the satellites column, and it has no fix in the fix type column. Let me just scroll down until it gets a fix. Here we go. Here. Oh, there it is. About a minute and a half in. So it took about 90 seconds or so. It switched from no fix to 3D fix. It switched from 0 satellites to 4 satellites. So the first thing I'm going to do for cleaning up purposes is I'm just going to erase all the data that has no fix. So what I've done here is I have highlighted the last no fix, and I just scroll up to the first no fix, and I'm just going to say delete. There it is. I just cleaned up the data, at least a little bit. Let me do Control S to save it. Okay. Let's think about what I want to do now. I want to graph sensor versus time. This is the most obvious thing to graph. You have sensor values and then you have times. And so for every given time, there is a different sensor value, perhaps. So if I want to graph sensor versus time, that means draw a graph with sensor on the vertical axis and time on the horizontal axis. And let me choose pressure. If I go over here, I see there are 4 pressure columns and they're poorly labeled. This one says PA. What it really should have said is pressure, PA. Okay, basically this is pressure in PA. Here's pressure in kilopascals. And the next one would be pressure in atmosphere as pressure in PSI. Double click here so I can read all of my writing. I'm going to plot this column, pressure in kilopascals, and this column, time in minutes. Here's how you do that with Excel. First of all, I click time in minutes, and then I click. Actually, I don't want to click the next one. I want to control click. If I were to click the next one, it would forget the first one I had chosen. If I shift click, it would grab all of them in between the first one and the last one. But if I do control click, it will only grab the 2. It's grabbed time and it's grabbed pressure. And now it's time to insert, scatter, chart. This is good. Basically, I can see, and this makes sense, steady pressure before I launch, decreasing pressure while I'm ascending, increasing pressure while I'm descending, and then steady pressure after I've landed. So this is a full balloon flight and at least some minutes on either side of it. That's good. One thing I particularly like about Excel is that if I have a graph, and if I click on the data in the graph, it tells me what has been graphed. And so all I need to do if I want to look at some other things is just drag this over. So for instance, I could look at, I'm just dragging this over to say external temperature, and the graph changes. Steady temperature, decreasing temperature, steady, and then increasing temperature, and then getting cold again, and then going back up at steady temperature. So in other words, I can rather easily see what's happening. So for instance, if I wanted to see um, the altitude in meters, steady, increasing in meters, decreasing in meters, steady. Okay, let's make this graph look better. But first of all, let's get the right graph. And the right graph is the pressure graph. So here it is, pressure in kilopascals. There's a few things that I don't appreciate about this graph. Um, One of the things I don't appreciate is this data point down here. I wonder how that got there. Right in the corner here. I suspect that that's related to the fact that the very first line here is a header line. Yeah, I think what I need to do, I think what I did is inadvertently I dragged this up one. I should have dragged it over and not dragged it up. Excellent. I got rid of that point that was way down here that I didn't like. Quick layout is a handy way. So for instance, if you click on a graph, it opens up what do you want to do with the graph? And what I want to do right now is I want to increase or improve the layout. I almost always use just the very first layout number one. And so layout number one gives me a place to put a title and axis title and axis title, overall title. So let me just put overall title as pressure versus time. And instead of you doing the units up there, I'm just going to type my initials as evidence that I was the one who drew this graph. Down here, this would be time since boot up in minutes. Over here, this would be pressure. Oops, clicked too many times. Pressure in kilopascals. I don't really appreciate that it says 0, 0.00, 50.00, 100.00. Let me get rid of those extra digits. Double click on the axis, go down to a number way down here, and tell it don't show me any extra decimal places at all. So I'm just going to change the decimal places to 0. Okay, that's handy. And you know, I would actually prefer that this was every 30 minutes. So I'm going to double click that and say, tell me what's happening every 30 minutes, not every 50 minutes. And in fact, maybe only go up to 180 minutes. Don't even bother going to 210 minutes. Last thing I'm going to do is I'm going to right click and say add major grid line. So now I have vertical and horizontal grid lines. I would say this is in pretty good shape. One thing I could do is I could delete this. If I delete this, it makes the graph bigger. In fact, if you have multiple things graphed, maybe a legend is important, but if I'm only graphing one thing, I don't really need to have a legend. If I right click on the data and say format data series, click on the paint bucket, click on the marker, click on marker options. Now I can make the dots smaller. So there's 2-point dots. I could potentially make them a different color too, you know, or a different shape, but I kind of like the round shape. And I could make it a different color, but I think I'm just going to leave the color alone as blue. There, I'd say that's pretty good, with the exception that this might be a little bit on the small side. But if you think that this is too small, as in, I could make this, 14 point or something like that. Looks like I missed one of the characters, 14 point. Let's say here I want this to be maybe also 14 point. This looks like it's 9 point. Let me make that 12 point. Let me make that 12 point. Looks like this is 14 point. Let me make that a little bit bigger as well. Maybe 20 point. Fair enough. So what's happening here is, especially if I'm going to take this and, make a copy and put it someplace else, I want to make sure that the writing is still reasonably readable. Again, this is what I would call sensor versus time. Sensor vertically, time horizontally. On the other hand, another important thing to be able to graph is altitude versus sensor. So altitude vertically, sensor horizontally. Why altitude vertically? Because, well, altitude is vertical after all. Altitude goes up. So I much prefer to have altitude vertical on graphs. Let me see if I can make such a graph. Let's say I'm interested in external temperature in Fahrenheit and altitude in feet. And again, control click. So here I have control click. So I have those two chosen. And let me insert not what I wanted. And the reason it's not what I wanted is it has altitude horizontally, but I wanted altitude to be vertically. Okay. Um, And why does it have altitude horizontally? And the reason is the first column, the leftmost column, is always the horizontal axis, and the rightmost column is always the vertical axis. So for instance, before I had a time on the left side and a pressure on the right side, so it drew time horizontally. Now I have altitude on the left side and temperature on the right side, and it's drawing altitude horizontally, and I don't want that. What to do? Well, you might be able to figure out, I don't know offhand, I could probably figure it out, how to tell Excel, switch it up and graph X versus Y instead of Y versus X or something like that. Here's another very simple fix though, and that is, let me go to this, what do I want to do? I just want to reverse the order of this column. So I want this column to be to the right of this column. That shouldn't be too hard. Let me do the following. This is going to seem a little clunky, but I'm going to click immediately to the right of external temperature. I'm going to say insert, so it opens up a column. And then I'm going to go over here and I'm going to say Control C to cut and Control V to paste. And so now I have altitude to the right of the temperature. So if I want to do this plot instead, insert, that's what I wanted. I want altitude to be vertical, and I want the temperature to be horizontal. Now, I could take some time, and I should take some time, frankly, to clean this up, but let's just take a quick look at what's going on here. One thing I notice is that there's some data points that are kind of scattered around. So it seems like this thermometer wasn't doing perfectly well, and those are few and far between, relatively speaking. So I could probably even ignore them or even erase them, I suppose. On the other hand, I noticed that when I'm on the ground, there's some variation in altitude without any, I'm sorry, some variation in temperature without any change in altitude. That's this long line right here. But then once I start to ascend, once I increase my altitude, the temperature goes down. And then eventually the temperature sort of steadies out. So this is called the troposphere, and this is called the tropopause, where the temperature has paused. It's not going down anymore. And then as I continue to increase above maybe 60,000 feet or so, the temperature starts to increase. That would be into the stratosphere. And eventually, the peak of this flight, close to 100,000 feet, the temperature gets reasonably warm. On the other hand, here's something that's a little bit weird right here. Right here is some data. And if you were to look carefully at the ascent data versus descent data, maybe by graphing them on separate graphs or on the same graph in two different colors, you would notice that these numbers here are ascent numbers, and these numbers here are descent numbers at the same altitudes. And so it's almost like the descent numbers are offset from the ascent numbers. Is that true? Probably not. Okay. This just tells me that there's something wrong with the way this data was collected. It might have had to do something with the fact that on the way up, we went up pretty slowly, and on the way down, we tumbled down really fast. And maybe the thermometer wasn't able to keep up or wasn't able to do a good job. I think the ascent data is probably more correct than the descent data, but I don't have a good explanation for why there's an offset, other than the offset seems to only be for a range of altitudes here and here, and then eventually the ascent and descent data apparently are lining up with each other pretty well because I don't see a separation of the two right here. Okay, again, I could fix up that graph if I want to, but this allows me to take a quick look at least. Final comment, labels. Remember the labels that were on the very first graph? It showed burst is here and launch is here and stuff like that. Labels are useful, especially if the data is hard to interpret. Like if you have a Geiger counter, which starts to increase its counts, but doesn't do so until after you've been flying for a while, it's handy to have a label that says launch was here, even though nothing special happened in the Geiger counter data at launch. It happened some minutes later once you reach 10, 15,000 feet. If you are doing ground testing, like with a PICOLO, then labels are even more important. And the reason is when you walk around, you go up and down steps, for instance, or up and down an elevator, the pressure will change, but it won't change in a predictable manner. It's like it depends on what you chose to do. Did you choose to go up first or down first or up 3 times and whatever? Okay. And so a label that says, here's where we got in the elevator and we went up. Here's where we walked around outside, and here's where we climbed the hill, and here's where we pointed it at the sun. And that's the sort of thing that labels would really help to interpret the data, especially if the data is not from a flight where I can kind of envision what's supposed to happen. I'm supposed to go high, the temperatures are supposed to go down, and then it's supposed to go up, and the pressure is supposed to go down, things like that. But if you're doing ground testing where you're walking around and I don't know how you walked and I don't know where you walked, then it would be useful to put labels on your graph to help explain the features of the graph and what they mean.